Jupiter, a giant among planets, reigns supreme in our solar system. Its massive size and gravitational pull influences the orbits of other celestial bodies. Orbiting this behemoth is a family of moons, each with its own unique characteristics. These moons range from tiny, irregularly shaped rocks to large, planet-like bodies, all contributing to the dynamic environment around Jupiter. Among them, one stands out a giant named Ganymede. This moon is the largest in the solar system, even bigger than the planet Mercury. It orbits Jupiter in roughly 7 days. Ganymede is a place of wonder with its surface covered in a mix of ice and rock, creating a landscape that is both alien and beautiful. Despite being the only moon in the solar system with a substantial magnetic field, it is the largest solar system object without a substantial atmosphere. Ganymede's surface is marked by deep grooves and craters, evidence of its turbulent history. It is a place of stark beauty, where the interplay of light and shadow creates a mesmerizing tableau. Ganymede and its fellow moons offer a glimpse into the complex and varied nature of planetary bodies. In the year 1610, the Italian astronomer Galileo Galilei pointed his rudimentary telescope towards Jupiter. He discovered 4 points of light that moved in a line with the giant planet. These were the Galilean moons, Io, Europa, Callisto, and the largest of them all, Ganymede. This discovery revolutionized our understanding of the solar system. It challenged the prevailing geocentric view, providing evidence for the heliocentric model. Ganymede, named after a Trojan prince in Greek mythology, became a symbol of this paradigm shift, a celestial giant forever linked to the birth of modern astronomy. Ganymede is truly colossal. Larger than the planet Mercury, and even dwarfing Pluto, it is the largest moon in our solar system. Ganymede appears to be fully differentiated, with an internal structure consisting of an iron sulfide iron core, a silicate mantle, and outer layers of water ice and liquid water. Its surface composed of 2 main types of terrain, a canvas of light and dark, the first of which are lighter regions, generally cross-cut by extensive grooves and ridges dating from slightly less than 4 billion years ago, covering 2/3 of Ganymede. The second terrain type are darker regions saturated with impact craters, which are dated to 4 billion years ago. The composition of this giant moon is a mixture of rock and ice. Ganymede may have experienced a period of heavy cratering 3 to 4 billion years ago, similar to that of the moon. Ganymede also has polar caps, likely composed of water frost. These polar caps were first seen by the Voyager spacecraft. Scientists believe that Ganymede has a differentiated structure, with a metallic core, a rocky mantle, and a thick icy shell. This icy shell is what makes Ganymede so intriguing, as it may harbour a hidden ocean beneath its surface. Ganymede's surface tells a tale of cosmic bombardment. Its craters are vast. Stretching hundreds of kilometers across the surface shows evidence of catastrophic impacts in the early solar system. As seen before, Ganymede's surface is a mix of 2 types of terrain, very old, highly cratered dark regions and somewhat younger, lighter regions marked with an extensive array of grooves and ridges. The dark terrain contains clays and organic materials that could indicate the composition of the impactors. Cratering is seen on both types of terrain, but is especially extensive on the dark terrain. It appears to be saturated with impact craters and has evolved largely through impact events. The density of cratering indicates an age of 4 billion years for the dark terrain, similar to the highlands of the moon. The patterns of cratering reveal a dynamic and violent past, a time when the solar system was a much more chaotic place. Jupiter's largest moon has long intrigued scientists with its mysterious and icy exterior. In the 1970s, NASA scientists first suspected that Ganymede had a thick ocean between 2 layers of ice, one on the surface and one beneath a liquid ocean and atop the rocky mantle. In March 2015, scientists reported that measurements with the Hubble Space Telescope confirmed that Ganymede has a subsurface ocean. Beneath Ganymede's icy shell there lies a vast ocean. This ocean is thought to be buried under a thick crust of ice, possibly tens of kilometers deep. Evidence suggests that this ocean could contain more water than all the oceans on Earth combined, and it could be the largest in the entire solar system. Imagine an ocean so immense that it dwarfs our planet's own vast bodies of water. As a result of these findings, there is increasing speculation on the potential habitability of Ganymede's ocean. The presence of liquid water is one of the key ingredients for life as we know it. Water is essential for all known forms of life, acting as a solvent and medium for biochemical reactions. The possibility of a vast hidden ocean on Ganymede challenges us to think about where else in our solar system or even beyond. The discovery of such an ocean not only excites scientists but also inspires future missions to explore these distant worlds. Ganymede is unique among moons for possessing its own intrinsic magnetic field. This magnetic field is thought to be generated by a dynamo process in its metallic core, similar to Earth's magnetic field. This magnetic field creates a magnetosphere around Ganymede, a region of space where charged particles from the Sun are deflected. The presence of a magnetosphere is significant because it can protect a planet or moon from harmful radiation, making it more hospitable to life. The combination of a subsurface ocean, organic molecules, and a protective magnetosphere makes Ganymede one of the most promising places in our solar system to search for life beyond Earth. While we haven't found definitive evidence of life on Ganymede, the potential is certainly there. Future missions to Ganymede will focus on searching for signs of life, both past and present. These missions will carry sophisticated instruments capable of detecting biosignatures, chemical fingerprints that could indicate the presence of life. Ganymede has been visited by several spacecraft, including NASA's Voyager and Galileo missions. These missions provided our first close-up glimpses of this giant moon, revealing its complex surface and hinting at its hidden ocean. In 2016, NASA's Juno spacecraft arrived at Jupiter and began a detailed study of the gas giant and its moons. While Juno's primary mission is to study Jupiter, it has also made several close flybys of Ganymede, providing valuable data about its magnetic field and internal structure. The future of Ganymede exploration is bright. The European Space Agency, or ESA, is currently developing a mission called JUICE, which stands for Jupiter Icy Moons Explorer, and it's scheduled to launch in the 20s. JUICE will spend several years orbiting Jupiter, making multiple flybys of Ganymede, Europa and Callisto. JUICE will carry a suite of instruments designed to study Ganymede's subsurface ocean, magnetic field, and potential for life. This mission promises to revolutionize our understanding of this icy world and could potentially provide the first evidence of life beyond Earth. This celestial body, larger than the planet Mercury, is a world of ice and rock with a magnetic field of its own. Its surface is a canvas of craters and grooves, telling a story of cosmic collisions and geological activity. Its discovery by Galileo Galilei in 1610 challenged our view of the solar system, revealing that not all celestial bodies orbited the Earth. This was a pivotal moment in the history of astronomy, marking the beginning of a new era of exploration and understanding. Today, modern spacecraft continue to study Ganymede. As we explore Ganymede and other worlds beyond our own, we gain a deeper appreciation for our place in the cosmos. We are but one species on a small planet orbiting an ordinary star in a vast and ancient universe. Yet this perspective does not diminish our significance, rather it highlights the preciousness of our existence. Our planet, Earth, is a rare gem in the cosmic ocean, teeming with life and possibilities. But even in our cosmic insignificance, we are capable of great things. Our curiosity drives us to explore, to seek out new frontiers, and to push the limits of what we know. The spirit of exploration is deeply ingrained in our nature, propelling us to venture into the unknown. Scientists and engineers work tirelessly to design missions that will take us further than ever before. Astronauts train rigorously to prepare for the challenges of space travel, embodying the human spirit of adventure and resilience. And as we continue to explore the universe, each discovery, each piece of evidence brings us closer to answering the age-old question, are we alone in the universe? The journey is long and filled with uncertainties, but the potential for discovery is boundless.